Lesson 7-7, Day 1, Geometric Sequences as Exponential Functions. Our essential question today is how do you write an equation for a geometric sequence? So we have one new vocabulary word, that is geometric sequence. A geometric sequence is a sequence with a pattern involving the same number being multiplied or divided over and over. The general form for a geometric sequence is f of x equals a times b to the power of x. Because this sequence has an exponent, it's a nonlinear sequence. So if we drew a graph, our graph would not be a straight line. It would be curved. And then notice that with our general form, it says where x equals 0, 1, 2, 3, and so on. So if we substitute 0 for x and solve that general form, that would give us the first term in the sequence. If we substitute 1 for x, that would give us the second term, and so on. So we're going to focus on a couple of different things today. Our question says, identify the common ratio and find the next three terms in each geometric sequence. So the common ratio means what is being multiplied by each time. So common ratio, the number multiplied by. So notice I did not say divided. The number multiplied by from one term to the next. All right, so the number multiplied by from one term to the next is your common ratio. So if we're going from 2 to 4 to 8, our common ratio is 2. It's multiplied by 2 each time. Then the next three terms, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. So this sequence has a common ratio of 2, and if we continue the sequence, our next three terms are 16, 32, and 64. Our next sequence, going from 3 to 12 to negative 48, our common ratio, what is multiplied by each time, will be negative 4. Negative 4. Because negative 3 times negative 4 is 12, and 12 times negative 4 is negative 48. So if I continue to multiply by negative 4 each time, negative 48 times negative 4 is 192. If I multiply that by negative 4, I get negative 768. And multiply that by negative 4, I get 3,072. Calculator can come in handy on this lesson. Our next problem, you may not be as good at figuring out common differences when you're working with decimals. So now would be a good time for me to point out that if you take two of your terms and you take the second term and divide it by the first one, that will give you your common ratio. So if you divide these terms, it gives you your common ratio. So dividing negative 1.5 by negative 0.5 gives you the common ratio of 3. Positive 3. A negative divided by a negative is a positive. So negative 4.5 times 3 is negative 13.5. Multiply by 3 again, negative 40.5. And multiply by 3 again, negative 121.5. Our next problem, if we go with what I just taught you and take the second term and divide it by the first term, you may see that this is actually not going to give us a really nice number at all. 10 divided by 50, or 1/5, is the same as 0.2. So you could use a fraction or a decimal in this situation. So I'm going to say 1/5 or 0.2. That's what it's being multiplied by each time. So 2 times 1/5 would be 2/5. And then if I multiply by 1/5 again, remember that you multiply your numerators and your denominators. So I would get 2 25ths. And then if I multiply by 1/5 again, I would get 2 125ths, like that. And again, you might see fractions, you might see decimals. Okay, our next one, we have 30 and negative 90. So 30 divided by negative 90 reduces to negative 1/3. I am definitely going to keep this one a fraction because it's a repeating decimal and I do not want to be rounding. So negative 10 times negative 1/3 is 3 1/3. If I multiply that by negative 1/3 again, I get negative 1 1/9. And multiply that by negative 1/3 again, I get 10 27ths. And our last problem, negative 6 divided by negative 12. So every time I'm taking the second term and dividing it by the first, gives me positive 1/2. So 1/2 or 0.5. So negative 3 times 1/2 is negative 1.5. If I multiply that by 1/2 again, it's negative 3/4. And then multiply that by 1/2 again, it's negative 3/8. So identifying the common ratio means you have to figure out what your sequence has been multiplied by from one number to the next. So the inverse of multiplying is dividing. So if you can't look at the sequence and see what it's being multiplied by each time, use that inverse of division. Divide the second term by the first one and then reduce it to figure out that common ratio. Then use the common ratio to get your next 3 terms in the sequence. Now we're going to change and we are going to answer the question, how do you write an equation in function notation for the geometric sequence? So to write an equation, f of x equals a times b to the x power, we need 2 really important pieces of information from the sequence. We need the first term in the sequence and the common ratio. So the first term in this sequence is 6. So f of x equals 6 times, because the a and the b are right next to each other, that means they're multiplied, 6 times the common ratio to the power of x. So this sequence, I can tell 6 times 3 is 18, 18 times 3 is 54, so I can tell that my common ratio is 3. So the sequence would be written like this with parentheses, or you may see it written like this, 6 times 3 to the power of x. Either one of those would be the correct answer. The next sequence, f of x equals, my first term on this sequence is 1, and what it's being multiplied by each time is negative 4. So f of x equals 1 times negative 4 to the power of x. In this sequence, if it was written with a dot, you would still need parentheses around the -4, like that. All right, our last slide. 120, 30, 75. Because this one is going down, I'm going to divide the second term by the first one. 30 divided by 30 is 1, and 120 divided by 30 is 4. So my common ratio for this sequence is 1/4. So f of x equals the first term, which is 120, times 1/4 to the power of x. This could look a couple of different ways. It could also look like this. 120, and it could be 0.25 to the power of x. It could also be written with the dot instead of the parentheses, like I did on the last problems. Still means the same thing. And the last one, 18, so the second term divided by the first, this would reduce to -1/2. -1/2. So f of x equals the first term, -36, times -1/2 to the power of x. And again, it could be -0.5. It could be a decimal form. And it could be written with a dot for multiplication. So a couple of different ways. The tricky part is figuring out that common ratio when you can't look at the sequence and just say it's multiplied by 2 or multiplied by 3. That's when it gets tricky. The division problems, so these two problems, you may have looked at it and said, well, I know they're dividing by 4, or I know they're dividing by -2. You still have to be able to express that division as a multiplication pattern instead. So remember that dividing by 4 is the same as multiplying by 1/4, because division is multiplying by the reciprocal. So dividing by 4 is multiplying by 1/4. Dividing by -2 is multiplying by 1/2. So very tricky concept to figure out. So this is the end of our examples. So take your time and remember my hint about dividing the second term by the first term if you can't figure out that common ratio right away. You should be able to write a summary now, answering the essential question. Make sure that you use complete sentences and restate the EQ.